Hello and welcome. This is our lecture video for the lecture on either August 31st or September 1st. Let's start with a quick review of how to solve and graph compound inequalities. Take a look at this problem, pause the video, copy it down. You should have your notes out as you're watching these. Alright, so to solve this, we need to solve the two halves. Put a box around both of our answers, write the word "and" in between. That'll be our algebraic solution, and then we're going to graph them. So in solving this, I want to isolate my variable on the left side of the inequality symbol. That means moving this negative 5n over to the left. Do that with an inverse operation, adding 5n to both sides, cancels on this side. On this side, it becomes a 14n. Alright, then I want to move everything else away from the variable, so that means subtracting 4 from both sides. I get 14n is greater than or equal to negative 14. Divide both sides by 14. And I get that n is greater than or equal to negative 1. I can put a box around that because my variable is isolated on the left-hand side. Alright, and this one over here, again I want to move the term with the variable to the left. Get negative 9 plus 6n is less than or equal to 9. Move my constant. 6n is less than or equal to 18. Get rid of the coefficient by dividing. It didn't happen in either of these, but if we ever divided by a negative, we'd want to flip the inequality symbol. Alright, and then our full answer, we want to still write the word "and" in between these two inequalities. So that's our algebraic solution. Let's put this on a graph. So I need a number line. Alright, start with this one. Gotta put the number -1 on my number line. I want a closed circle at -1 because this has the or equal to part. Arrow going to the right. I'm not going to finish that arrow, I'm just going to imagine it's going all the way off over this direction. Alright, for this one, I'm going to put a closed dot at 3. Arrow going to the left. And because it's an "and," we only want the overlap. So the only overlap is going to be this line segment in between -1 and 3. Okay, goal for today is to be able to solve equations containing absolute values and check for extraneous solutions. Why are we doing this? Well, it's time to start talking about absolute values because those give us another way to talk about change. Specifically when we don't care about whether change is positive or negative, just that something changed. Okay, absolute values. What is it? So it is an operation that tells us the distance a number is from 0. Alright, and distances are always positive. We never talk about a negative distance. Alright, and what does an absolute value look like? It looks like straight brackets. For example, the absolute value of 8. And that's how we would say this. We would say the absolute value of 8. That word "of" is important. You can't just say absolute value 8. Doesn't sound quite right. Alright, when is it useful? So distances. because it tells you the distance a number is from 0, we can use it for lots of other distances. or just anytime, whenever you want only positive numbers. So, I don't care if something's going up or down, just how much it's changing. All right, and here is an example where we might see absolute values. So your bank has a policy that you must have at least $500 worth of transactions every month, or you'll be charged an inactivity fee of $7. Below is the list of transactions for July. So when we're trying to figure out total transactions, we don't care if it's a deposit or the withdrawal, they all count the same. So let's add these up, see if we have at least $500 worth of activity. Let me get my calculator out. So again, I treat all the numbers positive. 345 plus 11 plus 24 plus 75 plus 85. We get a total of $540 worth of transactions. So, did you get charged a fee for July? No. We had enough activity in our account to show that we're using it enough not to be charged. If you started with $0 in your account, how much do you have at the end of the month? Do you have $540 in your account? No, we have to treat these as positives and negatives. So now we're going to treat this as a 345 minus 11 minus 24 minus 75 plus 85. All right, now the withdrawals count as negative numbers and the deposits count as positive numbers. And let's calculate this. 345 minus 11 minus 24 minus 75 plus 85. We have $320. All right. So an example of when we would use absolute values, and we get a very different number when we use absolute values. All right, let's evaluate some absolute values. So when I'm taking the absolute value of -7, I say, how far is -7 from 0 on the number line? Well, it's 7 units away, so it becomes a +7. Absolute value of 0, that just stays right at 0. 0 is 0 units away from 0. Absolute value of 55 is 55. So we could say absolute value brackets multiply negative numbers by -1 to make them positive, and then they leave positive numbers alone. That's one way to think about what they're doing. So what do we do if there's a variable inside of the brackets? So what if we have something like the absolute value of x equals 4? So we want to find all possible values that make this true, so we have to consider both the possibility that x is positive or negative. So we'll call that the positive case and the negative case. So in the positive case, we're assuming x is 0, so we're just going to drop the brackets. All right, if x is positive, those brackets don't really have a job to do, so they just go away. We'll say drop the brackets. All right, but let's also consider the scenario where x is negative. We'll call this the negative case. In the negative case, we need to change that negative back to being a positive, because that's what the brackets do. And so an operation that would do that is multiply by a -1. So make this negative parentheses x equals 4. So in the negative case, we're going to need a little more space. We're going to replace the brackets with a negative parentheses. All right, and now this requires a little bit more solving. We need to divide both sides by -1. And we get x equals -4. So there are two possible numbers that I can plug in to make this true. Or if we just ask this with words, we'd say, what number, when you take its absolute value, do you get a 4? Well, you can take the absolute value of a 4 and get 4, or you can take the absolute value of -4 and still get 4. So we get two answers. All right, let me just sort of add something to this. So in this scenario, we got two answers. It's possible to get no answers. So if you have the absolute value of x equals a negative number, every absolute value is positive, so this here has no solution. All right, if you got the absolute value of x equals 0, well, there's only one way to make this 0. It's only by plugging in a 0, so this one has one solution. And if you have the absolute value of x equals a positive, this always has two solutions. A positive and a negative that make that work. All right, good thing for your notes right there. So, absolute value of x equals -9. Well, we could use those same steps and split this into the positive and the negative case and say x equals -9 and negative parentheses x equals -9, and then this one divide both sides by -1, and we would get x equals 9. So these are the steps I just taught you, but these answers do not work. All right, if you tried plugging them back in, the absolute value of -9 is +9, not -9. So these don't cause it to balance. So these are what we call extraneous solutions. All right, they look like good solutions. We reach them through the normal algebraic steps that we would try with a problem like this, but they don't count. They're extraneous. All right, and extraneous solutions can hide, especially if we've got lots of other operations around the absolute values. But a good check is whenever you get it down to absolute value equals a number, if this is negative, you're going to have no solution. So this is, for our final answer, you say x equals nothing, the null space, not a 0, but no solution. All right, what if we've got a full expression inside of our absolute value brackets? All right, so to deal with this, we need to consider both that this piece in here could be positive or negative, depending on what x is. So we're going to split it into the positive and the negative case. So positive case, negative case. All right, in the positive case, the value inside there is positive, so the brackets don't have a job to do, so we drop the brackets. 2x minus 1 equals 5. The brackets just disappear. Let's go ahead and just finish solving the side of the problem. 2x equals 6, divided by 2, divided by 2, x equals 3. This is one possible value for x. Plug it back in, it is going to make it balance. We get 6 minus 1 is 5. The absolute value of 5 equals 5. That's a true statement. All right, in the negative case, we're saying this expression in here is negative, and the absolute value brackets have to flip it back to being positive. They do that by multiplying it by a -1, so we get negative parentheses, 2x minus 1 equals 5. We'll distribute in that negative, get negative 2x plus 1 equals 5. Move our constants away from the variable. Negative 2x equals 4. Divide by our coefficient. X equals -2. So it's both of these. We have two answers, a 3 and a -2. Let's try plugging in that -2. That would get us -4 minus 1, -5. The absolute value of -5 equals 5. Yep, that's another true statement. All right, what do we do if we've got an operation outside of the absolute value brackets? So copy this one down, and then our notes, we want to move this before splitting. Two T's in splitting, I don't know. You can call me out on that if I spelled that wrong. All right, we really want to isolate the absolute value brackets, so we add 7 to both sides. We get the absolute value of 2x minus 1 equals 21. Now we can split it into the positive and the negative case. 2x minus 1 equals 21. And negative parentheses, 2x minus 1 equals 21. And now it's just as simple as solving these multi-step equations. X equals 11 for one of our answers. And x equals negative 10. All right, plugging back in, make sure they work out. Let's see, that become a 22. So that's a 22 minus 1, 21. Absolute value 21, negative 7 plus 21 is 14. 14 equals 14, this one works. Negative 10, so negative 20, negative 21. That becomes a positive 21, minus 7 is 14, 14 equals 14. This one checks out. Okay. All right, another one. Pause video, copy it down. Here we go. We want to isolate the absolute value brackets before we split it into the positive and the negative case. That means getting rid of the constant first. 2 times the absolute value of x plus 4 equals negative 2. Divide both sides by 2. The absolute value of x plus 4 equals negative 1. And now that the absolute value is isolated, we can split it into the positive and the negative case. We'll say that that quantity is positive, so the brackets can just be dropped. Or we'll say it's negative, so the brackets have to flip it back to being positive. All right, minus 4, x equals negative 5. Plus 4, negative x equals 3, divided by negative 1, divided by negative 1. X equals negative 3. Put a box around both answers. All right, I'll put a couple more questions in here. That ends our video. I'm just going to look up if splitting has 2 T's or 1. It has 2 T's. So I spelled it wrong. Well, we all learned something here today. All right, have a good rest of your day.